Since the dawn of history, humanity has gazed up at the star-studded sky. Were these celestial bodies swimming in an infinite, eternal, and unchanging sea? Or did this vast existence have a beginning? For centuries, the prevailing belief was that the universe was static and timeless, but this conviction was about to be shaken. Hubble discovered that galaxies are moving away from us through a phenomenon called redshift. Much like how an ambulance's siren changes pitch as it speeds away, galactic light shifts toward the red spectrum. This was the definitive proof. Our universe is not static, but expanding continuously, like rising dough pushing everything further apart. If the universe is expanding now, it must have been smaller in the past. Imagine watching a film of an explosion and then playing it in reverse. The fragments would draw closer and closer until they converge into a single, infinitesimal point. This point is the beginning of everything. By determining the rate of expansion, scientists were able to calculate the time it took for the universe to expand from that single point to its size today. However, calculating the age of the universe wasn't as simple as pressing a button. Scientists needed to determine a magic number known as the Hubble Constant. This number tells us exactly how fast the universe is expanding. At first, estimates were wildly inconsistent. Some argued the universe was 10 billion years old, while others claimed it was 20 billion. There was a massive gap, and the search for more precise evidence had to begin. While scientists were debating the numbers, unexpected evidence emerged. In 1964, scientists Penzias and Wilson captured a strange noise in their instruments. At first, they thought it was a malfunction or interference, but they soon discovered it was the oldest sound in existence. It was the cosmic microwave background, CMB, radiation, the echo of the Big Bang that fills the sky. This discovery not only confirmed that the universe had a beginning, but also provided us with the golden key to calculate its age with astonishing accuracy. Using modern satellite data from missions like Planck and WMAP, it is no longer a matter of guesswork. We have measured the expansion rate with extreme precision. Imagine it as assembling a giant jigsaw puzzle. Every piece is a scientific clue, and when the final piece was placed, the number emerged with stunning clarity. 13.8 billion years. This isn't just a number, it is the age of everything we know, the age of time and space itself. To help you visualize the magnitude of this number, let's compare it to what we know. Our planet, Earth, with all its history and mountains, is only 4.5 billion years old. This means the universe existed, with galaxies scattered throughout, for 9 billion years before Earth was even born. We are living in the final chapter of a story that began much earlier than we ever imagined. We are literally stardust, living in a universe that has aged, yet continues to amaze us. You might wonder, how can we trust this number? Science doesn't rely on guesswork, but on cosmic yardsticks. We use specific stars that act as standard candles. Because we know their true brightness, we can calculate their exact distance from us. It's just like knowing how far a car is at night based on the intensity of its headlights. The further the distance we measure, the more accurately we can calculate the time it took for that light to reach us. But the journey didn't end with visual measurements alone. Scientists discovered that there are hidden passengers in this universe: dark matter, which acts as the glue holding galaxies together, and dark energy, which pushes the universe to expand faster and faster. Without understanding these forces, our calculations of the universe's age would have been completely wrong. It took decades of computer modeling to understand how attractive matter slowed down the expansion in the beginning and how dark energy is accelerating it now. In science, a final answer is often just the beginning of a new question. Recently, a mind-bending problem has emerged called Hubble Tension. When we measure the age of the universe using the cosmic microwave background, we get one number. But when we measure it using nearby galaxies, we get a slightly different result. This small discrepancy might mean there are laws of physics we have yet to discover, or that the journey to find the universe's true age still hides major surprise. Our quest to determine the age of the universe is ultimately a journey to understand ourselves and our place in this vast existence. After 13.8 billion years of expansion and intricate design, our existence today is nothing short of a miracle. While science opens the doors of discovery, contemplation provides the meaning. When we look at the stars, we are reading the oldest book ever written, a masterpiece of wisdom and power, and we are still only on its very first pages. A vast universe awaits us. Perhaps one day we will unlock all its secrets.